Gel electrophoresis is a laboratory procedure used to separate biological molecules with an electrical current. In this lesson, we'll review how agarose gel electrophoresis works and introduce the equipment necessary to perform an electrophoresis experiment. Separation of DNA molecules of different sizes can be achieved by using an agarose gel. Recall that agarose is a polysaccharide that can be used to form a gel to separate molecules based on size. Because of the gelatin-like nature of agarose, a solution of agarose can be heated and cooled to form a gel in a casting tray. Think of casting the agarose gel like pouring hot gelatin into a mold. The hot agarose liquid is poured into a casting tray. Once the mixture cools, a thin agarose brick will form. To ensure there's a place to put the DNA in the gel, a comb is placed in the agarose liquid before it cools. Each tooth in the comb will become a hole or well in the agarose gel. Once cast, this gel is placed inside a piece of equipment called a gel box. An electrode, one positive and one negative, resides at each end of the gel box. The wells are always oriented so they're farther from the positive electrode. This ensures that the DNA molecules in the well must travel through the majority of the agarose gel, thus providing sufficient time for separation. Air isn't a great conductor of electricity, so we cover the gel with electrophoresis buffer. Electrophoresis buffer is a salt solution. It isn't table salt, but the salt ions can carry an electrical charge just like salt water can. The salt in the electrophoresis buffer completes the circuit between the positive and negative electrodes. When the electrodes of the gel box are connected to a power supply, electricity flows through the electrical circuit, causing the negatively charged DNA molecules to move into the agarose gel. The DNA molecules continue to travel through the agarose toward the positive electrode as long as an electrical current is present. Recall that shorter DNA molecules travel through the agarose faster than longer DNA molecules. In this way, agarose gel electrophoresis separates different DNA fragments based on size. Recall that we can use another kind of buffer called loading buffer in the DNA samples. Loading buffer adds color and density to the DNA samples so they can be inserted into the wells in the gel. Once the samples are loaded, the electrical current supplied by the power supply not only moves the DNA samples through the gel, but the dye molecules as well. Note the colored lines that appear. These lines do not represent the DNA fragments. These lines represent the dye in the loading buffer that was used to visualize the samples during the loading step. The fastest traveling dye line is usually referred to as the dye front. Since DNA is invisible until the ethidium bromide staining step, this represents the second function of loading buffer, a means of tracking the progress of electrophoresis experiments. Scientists use the dye front as a means of ensuring that the DNA they wish to study doesn't accidentally shoot off the end of the gel. Generally, a dye is chosen that runs faster than the DNA fragments. Therefore, as long as the dye is still visible, the DNA is still in the agarose gel. Once the gel run is complete, the agarose gel can be removed from the gel box and soaked in an ethidium bromide solution. Recall that ethidium bromide is used to visualize DNA. Ethidium bromide molecules intercalate or insert between the nitrogenous bases in a DNA molecule. Since ethidium bromide fluoresces when exposed to ultraviolet light, the gel must be placed on a UV box to visualize the DNA fragments. To protect themselves from ultraviolet light, scientists typically view the gel through a glass shield or wear protective eyewear. Note that all DNA fragments of the same size appear as a single band fluorescing in the gel. The more molecules that accumulate at the same position in the gel, the thicker and brighter a band will appear. In summary, gel electrophoresis is a laboratory procedure used to separate biological molecules with an electrical current. Together with a gel box and a power supply, An agarose gel can be used to separate DNA molecules based on size. Loading buffer enables scientists to insert DNA samples into the wells of the agarose gel. Once the electrophoresis procedure is initiated, the dye in the loading buffer forms a dye front that is used to determine when the procedure is complete. When the electrophoresis procedure is complete, the agarose gel can be soaked in an ethidium bromide solution to visualize the DNA bands on a UV box.